Hi everyone, I'm Yuzhou from CSIRO Australia. I'm excited to share our work titled PerLA, Perceptive 3D Language Assistant. Developed in collaboration with colleagues from Fondazione Bruni Kessler and GKU Linz, this project advances the field of 3D language understanding by addressing key limitations in current approaches. So, in this presentation, I will walk you through the motivation behind the PerLA, the design of our framework, and both the quantitative and qualitative results we achieved on benchmark datasets. Recent methods like 3D large language model rely on multi-view image inputs to inject 3D awareness into the language models. However, this comes at the cost of high computation and often lacks accurate 3D spatial understanding, which limits performance in tasks like visual question answering. To address this, 3D native approaches such as LL3DA operate directly on point clouds. These are more efficient and spatially accurate, but their performance degrades when high-resolution point clouds are downsampled. Important local details are lost in this process. So this led us to a key question. How can we preserve fine-grained spatial detail while keeping the system efficient? Well, our insight was to replace naive partitioning with a Hilbert-based space filling curve, which ensures geometry-aware and symmetrically consistent partitioning of the 3D scene. And here's our solution. As is shown in the slides, which is the full pipeline of our PerLA, we begin with a shared 3D encoder to extract geometric features. These features are processed by prompt encoders and multimodal adapters that integrates language and visual inputs. Crucially, we incorporate localized cross-attention and GCN message passing to refine the fused representations. Now, let's take a closer look at the workflow. We start by applying Hilbert-based partitioning to divide the point cloud into coherent local regions. For each region, we extract both global and local point-wise features using a shared encoder. Then we perform k-nearest neighbor search within each region to model local context. Finally, features from each region are aggregated through localized cross-attention and refined with GCN, producing a unified scene representation that is well aligned with language. Let's look at our results on 3D question answering using the SCAN QA benchmark. PerLA consistently outperforms previous methods across all evaluation splits. Compared to LL3DA, we improved the starter score by up to 2.3 points. Along with the gains in Blue4, Meteor, and Roche, this demonstrates PerLA's superior ability to preserve and reason over fine-grained geometry. We also evaluated PerLA on 3D dense captioning benchmarks, SCAN Refer, and NR3D. Again, our methods outperform the state-of-the-art models across all metrics. On SCAN Refer at 0.5, we achieve a starter score of 69.41 over 4 points higher than LL3DA, showing that PerLA can generate more accurate and descriptive captions grounded in 3D geometry. Let's now look at a few qualitative examples. In question answering, PerLA provides more precise and contextually accurate responses than LL3DA. It demonstrates better object grounding, improved spatial reasoning, and even corrects object counts that LL3DA gets wrong. For dense captioning, PerLA generates richer, more spatially aware descriptions. It can distinguish object types, orientations, and relations to nearby objects. Those details often missed by baseline methods. We also conducted application studies to validate the contribution of each module. Removing GCN or isolating local or global features results in noticeable performance drops. Furthermore, we experimented with different partition counts and found that 6 parts offers the best trade-off between data preservation and computational cost. To summarize, PerLA extracts both global and local features via a shared 3D encoder. It uses localized across attention and GCN to integrate information across scales. And it leverages Hilbert-based partitioning for spatially consistent, geometry-aware presentation learning. These design choices allow PerLA to deliver state-of-the-art performance on multiple 3D language benchmarks. Thanks for listening. If you are attending at CVPR 2025, we'd love to meet you in person at poster number 355 on July 14th from 10:30 to 12:30. Feel free to reach out with questions. We look forward to the discussion. Thank you.